Good morning. Today I will try to go through chapter 6, which is about eigenvalues and eigenvectors. It's really very nice chapter. All the information, we had a lot of this information based on our previous experience, but it is an easy chapter. All I need from you is just to focus with the first problem, and you will find it's, first of all, it's accessible and it's really easy to understand. Okay, let's start. I will go with eigenvalues and eigenvectors. Reasons for the use of eigenvalues and eigenvectors. Why we use eigenvalues? We use eigenvalues and eigenvectors because it makes your life easier in some cases. For example, is it easier to evaluate this matrix to the power of 10 or to evaluate that matrix to the power of 10? Which one of them is going to be easier? If you look to both matrices, you will find one of them is a diagonalized matrix or a diagonal matrix. If you try to multiply a diagonal matrix in itself for 10 times, you will end up having the elements of the diagonal to the power of 10. So it's going to be negative 1 to the power of 10, 3 to the power of 10, 2 to the power of 10, and that's it. So it's not even comparable to deal with another matrix with four elements in the general case like this one. So this is mainly the main reason that we prefer to deal with diagonal matrices. By the end of the previous chapter, we already saw this equation, which states that we can get similar matrices. If I get a similar matrix for A, which is a diagonal matrix, it's going to be easier for me to deal with. How to get this A matrix? I will have to have first the P matrix, which is responsible about this diagonalization process. We will see today how to get this B matrix. Okay? معايا شباب؟ طبعا, if A is similar to a diagonal matrix, then we can take advantage of its properties. ده الهدف من اللي انا هعمله دلوقتي. ان انا بعمل diagonalization. طيب, انا هتكلم الاول in this lecture in two parts. The first of them, we will talk together how to get the eigenvalues of a matrix, how to get the characteristic equation, which is very, very simple, how to solve for the eigenvalues, then getting the corresponding eigenvectors. From these eigenvectors, we can simply perform the P matrix that's responsible about the diagonalization process that I told you about. Okay? So this is going to be the steps of this lecture. We will go back slowly. We will get back to many slides shortly, inshallah. But for now, I need you to understand the steps, the technical part of these steps, in order to get the eigenvalues and the eigenvectors. It starts with, let A be a square matrix. A non-zero vector U is called an eigenvector of A if and only if there is a number eta. So some number, it's called eta, real or complex, such that A times U equal eta times U. So I'm searching for a vector that if I multiply it in a matrix, I can get another number, which if I multiply in this vector, I will find them both equal to each other. This is what's called, or this is mainly the eigenvalues, which stand for the value of eta or lambda. معايا Monsieur Ibrahim? Second step, if I move eta u to the other side, I will end up having AU minus eta u equals 0. If you take U, which is matrix, okay, a column matrix, if you take it as a common, you will end up having this form. A minus eta I, the unit matrix, okay, times U equals 0. This equation is really very important. If you give it a look, you will find two values multiplied with each other and the result equal to 0, which means either U equal to 0 and you need the value of U. So if U equals 0, it's the trivial solution. Okay? So it doesn't mean anything. You will get U vector equal to 0. which makes sense if multiplied in anything will equal to 0, so it's a trivial solution. So I'm not going to consider this. I'm going to look for a minus eta I, which is going to equal to 0. And this part of this equation will help me to get the values of eta, which are the eigenvalues. Once I get the values of eta, I will resolve this system for a homogeneous system of equations, and I will get my eigenvectors by finding the values of eta. This is the whole scenario that we are going to go through step by step. Okay, so mainly for the time being, all I have to do is to just get a solution for this equation. These are the steps. In order to get the solution, bottom line, I will make a characteristic equation or finding the determinant of this matrix, which is A minus eta I. This determinant should equal to 0. So if I get the value of this determinant, which equal to 0, this is what we call a characteristic equation of a matrix. Once you solve it for eta, you will get the values of eigenvalues. Let's cut all these details and take a problem, okay, a simple one, just to go through the main steps of how to evaluate the eigenvalues and the corresponding eigenvectors. If I got them, I can get what's called an orthonormalized matrix. So if I got eta, which is the eigenvalues, and I got the corresponding values, I can get the orthonormalized model matrix. I call it this way in my in my book, in this part. Then I will check that U transpose times U equal I. This is a special case. And then we can get UT times A times U equal diagonal matrix. And U transpose here stand for the inverse of the model matrix. So it is, the inverse of the matrix, because the orthogonal matrices has, or the orthogonal matrix has a very specific property that its transpose is its inverse. So I can diagonalize this matrix this way. Right. First step, let's look to the matrix. I'm going to talk about 2 by 2, and it's going to be the same procedures with 3 by 3. Right. How to evaluate the eigenvalues of this matrix? If you look to this matrix, I have a 2 by 2 matrix. So all I have to do, first step, Mr. Muhammad, Ms. Malak, the first step now is to get eigen values for this matrix. So all I have to do is to make a substitution in this form, which states that A minus lambda of I equal 0, lambda or eta or whatever, where eta or lambda stand for eigen values. So if I make this substitution with this matrix, it means I will deal with a determinant of a matrix which the A minus lambda I Ms. Malak. If I subtract it from this matrix lambda I, معايا Ms. Malak? الريزلت يبقى شكلها عامل ازاي؟ If I subtract it from this matrix minus lambda I, what's gonna be? I will write the matrix step by step. The matrix is 9, 2, 2, and 6 minus lambda times I. I in this situation will be a 2 by 2 unit matrix. And so the result will be simply 9 minus eta, 9 minus eta, then I will have 2, then 2, 6 minus eta. Am I right? أنا كده صح؟ معايا مسمعك؟ اوكي يبقى دي الفيرست ستيب ان انا هعمل السبستيتيوشن اللي انا بكلمك عنه. طيب السكند ستيب I will try to form the characteristic equation مش زي دي. ازاي to form the characteristic equation? All I have to do is to get the determinant of this matrix. تعال نجيب الديترمنت بتاع الماتريكس دي. شكله ازاي مستر احمد؟ هيبقى عندي 9 minus eta, then I will have 2 and 2 and 6 minus eta. Mr. Ibrahim, solve, get the value of this determinant.
9
يبقى ده هيديني 9 minus lambda times 6 minus lambda, don't forget, minus 4. The equation states that this value should equal to 0, which is called the characteristic equation. اللي انا شايفه ده اللي هو بيطلق عليه ايه؟ characteristic equation or polynomial. Okay, try to expand. لما اجي افactorize it or expand it هتلاقي ان الشكل بتاعك اصبح كالاتي. So it's gonna be lambda, okay, square, negative lambda times negative lambda, you will end up having lambda square. Negative 6 lambda, negative 9 lambda, so you will have negative of a 15 lambda. Then I will have 9 times 6, which is plus 54 minus 4. So you will end up having a quadratic equation. صح مسير أحمد? So it's gonna be lambda square minus 15 lambda plus 50 equal 0. I'm solving for the values of lambda. اللي هم Eigen values. طيب ازاي how to factorize it or how to go through it? It's very very simple. All I have to do in order to solve such an equation is once more trying to factorize it. So I will have lambda 50, it's gonna be, let's say 10 and 5. Remark, I know it's really very simple for you. I have this sign which is positive. When you have the third term, positive sign, it means you are searching for two numbers, their multiplication equal 50 and their addition equal to the value in the middle. So 15. What's the two values that once you multiply each other, you will end up having 50, and their sum equal 15, 5 and 10. So, and the sign of course will go for the middle, same like the middle coefficient, so it's going to be negative, and the negative equal 0, and this will lead to lambda 1 equal positive 5, and lambda 2 equal positive 10. These are the two values of lambda. Do the two values of lambda. Remark, this is a matrix 2 by 2, so I end up having just only two values of the eigenvalues. Each eigenvalue will be assigned to an eigenvector. So I will once more try to solve the system of homogeneous equations, which stand for, this is second step. The second step is to get the eigenvectors corresponding for each eigenvalue. اروح اجيب U1 which is corresponding for lambda 1 وهنا evaluated to be 5. How to solve for them? It's really very simple. All I have to do is to get A minus lambda I and solve this system times the vector, the first vector, which equal to 0. Now I'm solving a homogeneous system of equations. طيب هحله ازاي? Very very simple. So I'm solving for the values of U1, which is the first vector, the first eigenvector. طبعا once you try to substitute with these values, I will have the A matrix, which is simply 9 minus lambda 1, which is 5. The second value is 2 and 2, and for the second principal or the second element on the principal diagonal, it's gonna be 6 minus 5. I'm solving the system, and this system is homogeneous, so the augmented matrix of this system will be exactly like this. That's 0 and 0. طبعا it's gonna develop a matrix like this. 9 minus 5, which is gonna be 4, 2, then I will have 0, multiplied by the second row, it's gonna be 2, 6 minus 5, which is 1, and 0. شباب اي مشاكل whatsoever؟ ايه اللي انا عملته؟ حد يقدر يقول كده من الاول؟
هنحلها.
انا مسكت الماتريكس، خدت البرنسبل دايجونال، عملت منه ماينس اكس ماينس ايتا ماينس لامدا، دي الفيرست ستيب. فورمد الديترمينانت، عملت له expansion, you will end up having a polynomial. If you are 2 by 2, it's going to be second degree polynomial. If it's 3 by 3, it's going to be cubic equation or polynomial. I've tried to solve it, so I factorize it, getting the roots of this equation. The roots are the eigenvalues. Now I'm trying to get the eigenvector corresponding to each one of them. Okay, so what I'm going to do, I'm going to do the same matrix, subtracting the values of the eigenvalues from the principal diagonal. So I will be ending like this. The question is, if this system can develop no solution?
No solution?
Yes. Is it possible to have a no solution for the system?
Yes.
ها؟
ممكن.
لا،
من ناحيه
مستحيل. ليه ما يطلعش؟ لأنه simply you are solving a homogeneous system. You are solving a homogeneous solution. Okay? Homogeneous system means إن ال results بتاعته بتساوي zeros. فمنين هيجي لك no solution؟ So you are between two things. Either infinite number of solutions or no solution. يا إما يجي لك infinite number يا إما no solution.
Can I get board?
This board?
No, not the board.
Marcus?
Markers?
Yeah, marker.
Yeah, okay.
Just one.
Try to see which one of them is working, okay? Okay? تمام? Okay, there you go. طيب, so you're either between two things. The first of them is to have a consistent unique solution or a consistent dependent solution or a consistent independent solution. 8 differences. 8 differences.
ايه؟ السؤال
لو أنا بجيب consistent dependent solution, so it means I will have infinite number of solutions, which is the case of a vector. If I have a unique solution or an independent solution for this system, it means that the vector will end up having 0 and 0. الفيكتور بتاعك يبقى ب 0 0.
هنا هتبقى زيرو.
يبقى هنا مستحيل انك تجيب independent set of solutions. You will have to get a dependent set of solutions. معايا مش زينة؟ ليه بقى؟ ليه لازم؟ لأن أنت حطيتي condition إنه الماتريكس بتاعتي دي will never be invertible. طب إيه الكونديشن اللي أنت حطيتيه؟ إن أنت استخدمت الأيجن فاليو اللي هي بكام؟ ب5 اللي هي بتوبليج إن الماتريكس دي لازم يبقى فيها at least two rows equal to each other or similar to each other. فلو ده ما حصلش انت غلط. Once you look to these two rows, you will find them either identical or there is a ratio between them. شوف انا بكلمك في ايه وان الرجاله بتلعب في الموبايل.
يا رجالة.
يعني ده معناه ان الاثنين اللي حضرتك شايفهم دول لازم يبقوا ده سيم اور في منهم برسنتج. طيب لو ده ما حصلش يبقى على طول عندك مشكله، يا اما في السبستيتيوشن هنا يا اما في الفاليوز بتاعت مين؟ الايجن فاليوز بتاعتك. طيب اوكي let's go ahead. Get the reduced echelon form. Is it simple to get? The first step علشان اجيب reduced echelon form اعمل ايه يا شباب؟
Divide by 2.
I think we can divide the first row by 4. لو انا عملت division للفirst row by 4 it's gonna be 1. Then I will have half and 0. Then I will need this value equal to 0. How to bring it to 0? I will multiply 1 by -2. Then I will add it on the second row. Okay, let's do it. -2 plus 2, so it's gonna be 0. -2 times half, it's gonna be -1. Plus 1 equal to 0. It will have to be like this. At least one of the rows equal to 0. So if you have a 2 by 2, one of them should equal to 0. If you have a 3 by 3 matrix, at least one of the rows should equal to 0. Okay, perfect. The step اللي بعده, I will consider this is the first vector and the first component. This is the first vector and that's the second component. I can take them as x and y. بس انا مش عايز اعمل contradiction مع البوينتس، فبتكلم على فيكتور with first component و second component. طيب start multiplication. Let's put them in an equation form once more. 1 times u sub 1, so it's gonna be u11 plus half of u12, which is supposed to equal to 0. لما انا عملت كده يا ملك، كده بقدر اجيب الكونديشن اللي بيعمل link between the first component and the second component. This is the condition that will link the first component and the second component. This is actually what's developing an infinite number of solutions. This is what's gonna develop a basis for the vector space of this eigenvector. Okay? طيب, second step, I will say that U1 is supposed to contain just only two components, U11 and U12. I will use this equation or this condition by substituting U11 by the value of negative half U12, the U12, replace U12 by any value that you like, or take it as a constant. يا إما أخده as a constant، يا إما replace it by any value that you like. طيب الفاليوز اللي ممكن تبقى هنا favorable تفتكر مين؟ مش زينة. تفتكري U12 أنا ممكن أشيله وأحط مكانه كام؟ ده خلاص أصبح negative half U12 وده U12. إيه الرقم؟ اختاري أي number from the real numbers just to represent it.
نيجاتيف
2. اشمعنى 2؟
عشان يتكلم
I have half. طيب لو أنا استخدمت half، استخدمت 2، I will end up having negative 1 and 2. يبقى أنا كل اللي أنا عملته I've chosen U12 equal to 2 in specific. ده كده اللي حضرتك شايفه ده كده السبان بتاع البيزس بتاع الايجن فيكتور سبيس الاول. ده كده اقدر احطه كده. لان اكشوال ليه ده عمل سب فيكتور سبيس مش زينه؟ ليه يعمل سب فيكتور سبيس؟ لان انت اخترتي رقم، لو حطيتي 2 هيديلك الفاليوز اللي هي نيجاتيف 1 و 2، لو كنت اخترت 3 كان هيديلك نيجاتيف 3 اوفر 2 و 3 صح؟ لو كنت اخترت 4، لو كنت اخترت 5، لو any number from the real set يبقى عندي infinite number من مين؟ من الفيكتورز صح؟ same procedures هعيدها تاني. بس المرة دي وانا بعيدها مع مين يا محمد؟ مع لامدا 2. يبقى انا كده I will get the value of the second eigenvector which corresponds for lambda which equal كام؟ 10. same way exactly like. يبقى انا على طول هروح اجيب الماتريكس بتاعتي اللي هي هتبقى كالاتي. ركز يا عمر. 9 minus 10 2 2 0 6 minus 10 equal to 0. الستيب اللي بعديها على طول اول ما اعمل السبستيتيوشن ده الاقي ان الفاليوز بتاعتي اللي انا بشوفها دلوقتي هي عباره عن negative 1 2 and 0. then I will have 2 4 and 0. تاني كده طبعا نيجاتيف 4. خلي بالك انا لو غلطت في ساين it's not gonna get good لان you can't find two rows exactly the same or there is a link between them. Of course now it's all set, more than perfect. So second step اعمل ايه؟ try to get it to a reduced echelon form. How to get it a reduced to the reduced echelon form? I will multiply by negative 1, so it's gonna be 1 negative 2 then 0. Then I will multiply by negative 2. Negative 2 plus 2 is gonna equal to 0. Negative 2 times negative 2 positive 4 plus negative 4 is gonna equal to 0, and this one also equal to 0. Exactly like what we did before. This is the second vector, first component. This is the second vector, second component. Try to expand it once more into an equation. Once we expand it as an equation, we will get the condition. So, you will end up having U21 minus 2U2 of 2, which is gonna lead to U21 will equal to 2 of U22. Now, I can write the second eigenvector, which contains two components. The second vector first component, the second vector second component. I will make the replacement. So instead of u21, I will replace it with 2 of u22. This is the second vector second component. It's a function in them. Now, anyone to suggest a value for u2 second component?
Half.
1.
1.
Why 1? I need them integers to make your life easier. فأنا لو عملت كده وخدت u22 equal to 1, I will have 2 and the positive 1. And once more, this is the space, or I'm sorry, this is the basis for the eigenvalues space.
It's U22 ب1 بقى.
ايه؟
نكتب له إن U22 ب1.
ماشي؟ اوكي. Let. Okay? وهنا let. Because I've just chosen this value. شباب، أي مشاكل؟ إيه المشاكل؟
I'm still confused about the concept. The concept itself.
You didn't attend it. I've spoke about it by the beginning. I have an equation
No,
which
I
is a
understand
minus
that
lambda
this
I
is
equal
the
to 0.
I understand
Okay.
that this is the
Okay. So
But
let's-
the part, why do we like randomly مثلا use a number? How do we just randomly?
this is a vector. This value and that value, it's equal to a constant. Yes. Now you have negative half u12, and this also u12. The value of u12 belongs to R, to the set of real numbers. So actually I can replace it by a constant. This constant is any number from the real set. I've just preferred to use 2 just to deal with integers instead of fractions. But it will make no difference. Use it the way you like it. Okay? اللي انا عملته دلوقتي انا جبت الايجن فاليوز وجبت الكورسبوندنج ايجن فيكتورز. في كومنتس كتير قوي، حاجات كتير قوي عايز اقول لك عليها ديتيلز قبل ما اخش في المين سلايدز، بس عايز تكمبليت ذس فيرست بعدين اقول لك الكومنتس اللي انا او البوينتس اللي انا عايز اتكلم عنها. في الوقت اللي انا عملته دلوقتي we can simply get the matrix P. خلي بالك انا بدات في ده في القصه دي كلها ليه مستر ابراهيم؟ حاسس ان دماغك بتطير فوق في السماء. انه لو انا عندي ماتريكس اسمها B اقدر اخليها تبقى similar للماتريكس اللي اسمها A if we get matrix B which its inverse gonna be B minus 1. If I make this happen, I will give or I will get a B matrix similar to matrix A. If I use certain conditions for P, I can make this matrix to be a diagonalizable matrix, which is a matrix similar to A, but in a diagonal form, which will make our life a lot easier in dealing with a diagonal matrix instead of dealing with a complete matrix. This is what we are searching for. Now I can simply get the value of the P matrix or the U matrix that I'm asking you about. All I have to do now is to get this matrix, which is U equal to. The first eigenvector will be the first column of this matrix. So, the first column is negative 1 and 2. The second one is 2 and 1. After doing this step, I need to get it on the ortho or the normalized form. The normalized step, it's not involved in your slides, but to give the main idea exactly, it has to be normalized. How to get a vector to be on a normalized setting? By dividing the components of this vector on its magnitude. ازاي بحوله او بعمل له كده عشان اخليه يونت فيكتور؟ طب اشمعنى لازم اقسم على الماجنتيود عشان اخليه تبقى نورماليزد؟ لسبب بسيط، انت من شويه اخترت اي فاليو فور U12 حصل؟ طيب علشان اخليه ستاندرد عايز اجيب الماجنتيود بتاعه يبقى بكام؟ بوزيتيف 1. طيب ازاي to force this vector to be on a normalized form? I will divide its components on its magnitude. طب ازاي بجيب magnitude of a vector؟ بسيط. I will divide by the square root of the sum of the squares of these components. يعني كل اللي انا هعمله ببساطه مستر محمد I will take the first component square which is 1. The second component square which is the sum of them will be 5 under square root. I will divide this vector on root 5. And for the second vector, same way like. Okay? So I will get the square of the first number which is 4. The square of the second number which is 1. The sum 5 under square root. So I will divide by root 5. Now I have the orthonormalized model matrix. So from this I can get the B matrix which is gonna be -1 over root 5, 2 over root 5, 2 over root 5, 1 over root 5. ده الماتريكس اللي انا بتكلم عليه اللي بتبريزيرف كل البروبرتيز اللي انا قلتها لك. ستوب. تعال بقى نعدي على بعض الريماركس تاني من الاول. ايه اللي انا عملته بسرعه؟ خليني اعيدهم تاني بسلايدز بعدين اكلمك عليهم وانس مور بالديتيلز اللي انا عايز اوضحها قدام عينيك. اول حاجه هعملها تعال نمشي بالستبس تاني اكني بنعيدها من الاول خالص. تمام؟ اوكي. First step, this is your matrix, which is 9, 2, 2, and 6. Second step, I will form this equation, which is simply E minus lambda I. Mr. Yusuf, سيب موبايلك. ما هوش موجود من الأول. شيله. اللي على وشه. خليك بقى معايا. أنا عندي A minus lambda I. But the first step, once more, this is the matrix. The first step, get the principal diagonal minus lambda. Principal diagonal minus lambda. Both the determinant equal to 0. This is what's called the characteristic equation. Try to solve this equation. How to solve this equation? Simply, I will get the multiplication of the principal diagonal minus the secondary diagonal. You will end up having a quadratic equation. Expanded. Simple. Then try to refactorize it and get the roots of this equation. Succeed. Lambda 1 equal 5, lambda 2 equal 10. Done. By the idea. Those roots for you may be real or complex. Okay? طيب أنا جبت الروتس التو واي بس the methodology it's the same. جبت الايجن فاليوز. هجو for the second step. مستر يوسف بجيب الايجن فيكتورز. هعمل ايه؟ همسك الفيرست ايجن فاليو which is 5. Then I will substitute in this system. But I will solve a homogeneous system of equations, which is simply A minus EI. E is the stand for the eigenvalues and equal to 0. Here I'm trying to get the value of U, which is the eigenvector, corresponding to these eigenvalues. Each eigenvalue have a corresponding eigenvector. Okay, perfect. على طول الستيب اللي بعديه 9 minus eta 2 and 2 6 minus eta equals 0 because you are solving a homogeneous system. Okay, done. This is the first value, lambda 1 equal 5. I will get to the principal diagonal elements subtracting 5 or the first value from from the principal diagonal. I will end up having a system like this. You will have to have either two rows equal to each other or there is a percentage or a ratio connecting them. If you just look to the first row, you will find 4, 2, and 0. The second one, which is 2, 1, and 0. There is a link between them, which is 2. Okay, I will try to get it to the reduced echelon form. This is the reduced echelon form. Just simply by dividing the first row by 4 ya Yusuf, then I will multiply by -2 the second row, it will disappear. Now I can have a condition connecting the coordinates of the first vector, which is gonna come up to this equation. the first vector first component plus the first vector second component equal to 0. Trying to solve, so u11 will equal to negative half of u12. This means the first vector contains two components. Simply, I will remove the first component and use or substitute by this value. Done. Now choose a suitable value, whatever you like. I will prefer to use 2 in order to deal with integers. Simple. Done. This is the first vector. For the second vector, I will resume all the steps once more. But at this time, I will use eta, which equal to 10, the second eigenvalue. Blah, 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 same way like, وصلت للكيس دي. Which means you have two identical lines or rows, or at least there is a percentage. Okay, try to get them to the reduced echelon form. Try to get the relation connecting these components. معايا مسمعك؟ Okay, perfect. Get u12 equal negative 2 of u22, which means one of them double the value of the other one. I made the substitution exactly like this one. Add a substitution between. Just to choose any value, Mr. Ibrahim. I prefer to use 1 to have integers, which is 2 and 1. تمام؟ في هنا حته كده انا كلتك فيها انت دايما، بس عشان يبقى الشغل بتاعنا ايديال تبقى انت فاهم كل حاجه. برنسس ملك قبل ما تخرجي بس لاحظي ان الماتريكس دي سيمتريك. اخرجي. الماتريكس دي سيمتريك. يعني ايه سيمتريك مستر يوسف؟ يعني ايه سيمتريك؟
Equal values across the mean diagonal.
Yes, exactly right. The principal diagonal values are different, but the values on the sides are the same. This is called a symmetric matrix. Symmetric matrices, لما بتجيب لها eigen values وتجيب لها eigen vectors, they have a wonderful property, especially if you get the normalized matrix, which is responsible in application